The purpose of this video is to help people understand the use of barcodes at point of care, specifically how to identify bad barcodes, and also to share some tips on good practices for barcodes. So remembering that we have certain objectives in the use of barcode in healthcare, and I'm going to try to redefine those in terms related to characteristics of barcode scanning and printing. We have an objective of increasing the precision or the accuracy of information. This relates to patient safety and the recording of consumed items and automatic replenishment in healthcare. We're interested in high productivity, a fast and easy use without forcing nurses to lose focus on patient care. We're also interested in generating useful information, data, real data, lots of data that we can use to make progress in the future. And we're interested in sharing this information instantaneously, virtually, with others in the healthcare environment so that they can make better decisions and maybe, stop the use of a certain item or the recall, to do recalls and traceability and things of that nature. So instantaneously sharing translates into added value for the data. So some of these benefits are easily identified, as in financial terms, but others are, way more than that, obviously. So there's a lot at risk. And a bad barcode puts a lot of this at risk. If you have one bad barcode, that one is affected. But if you have lots of bad barcodes, it could affect the entire project. So the idea is to try to nip these in the bud and try to get rid of them quickly, and get the culture of good barcodes embedded in our healthcare system. So the really good news is that bad barcodes are avoidable. There are systems for checking, and there are things you can do to identify bad barcodes before they hurt. So how do you tell if you have a bad barcode? This one that you're looking at here is a UDI, and as you can see, it scans very easily, very fast, and it actually scans within less than a second. It's that quick. And it'll do that with any scanner. Any scanner that is designed correctly, it'll scan it very quick. So that's a good barcode. So let me take a chance to take a look at a different barcode. This is a very small barcode. This is found on a lab sample. And you will see that it is unlike the other one. It has some difficulty scanning. And I know the characteristics of this one are that it's too small. It's a very small X dimension. The narrow bars are too small for this scanner to see it. Also, it's a bad barcode. It's an F, a grade 0. But having said that, the other scanner that I was using can see it with difficulty. So some people might pass that by and say, well, it did scan with my barcode. And the reality is that when you have a problem with a barcode that's slow to scan or requires the operator to move around and check different angles and stuff like that, it's an indication that there is a problem with that barcode. And the majority of the problems in scanning are traced to barcodes, not the scanner. This one, like I said, is a grade 0, an ISO grade 0. A lot of people would let this go, and in my case, in my idea, I would not let it go. I would try to nip this in the bud. It's an indication that there's something wrong. In this case, they need to use a larger X dimension, and they need to print an ISO grade 3, 4, or 2 even, but something better than a 0 for sure. And that will make it easier to scan. So how do you tell? like we just said, if it's slow to scan or difficult to scan or not able to be scanned, or in worst case, if it generates the wrong information, all which happen, then it's time to stop and take a look at it. So that is the first thing you do. You take a look at it and you examine it by eye. You see if it's really small, if it's been smeared, which would happen in a healthcare environment, if it's been scratched or covered by a film, or it's creased, or if somebody has accidentally put a grease mark on it, a check mark, saying it's check mark. If it's applied to a see-through kind of a material, a plastic material that you can actually see the product behind the label, that usually is a problem. Or if the quiet zones, there's actually a little bit of an area on the left and right of barcodes called the quiet zones that is required to make the barcodes easy to read by the scanners. If those are missing or impinged on, it's a problem. So if you don't see anything with your eye, nothing too obvious, then you can use a verifier, should use a verifier to check the ISO quality of the barcode. That'll tell the detail of what's wrong with the barcode, what is the characteristic of the barcode that caused it to fail. And you can share that information with the manufacturer, whoever printed the barcode. Or it may be, like this, a lab sample that was printed within the hospital. So if it's bad, you send that report to whoever printed it. If it's good, you can take another look at it and test what the X dimension is. If the X dimension is very, very small, then it may be out of the range of barcodes that your particular scanner can handle. And I showed you that this one cannot handle that, whereas this one has different optics and it can handle it. So check the X dimension. It may be out of specification because of the X dimension. Anyway, a verifier is required to do that kind of stuff. And again, follow up by sending the report to the manufacturer or the label producer and ask for corrective action. It is important to follow up and shoot for a resolution to all these types of problems, especially early on in the UDI program. Remind everybody that an ISO grade of 2 is the minimum required print quality grade, and on most of the printers that print these types of labels, a grade 4 or 3 is within pretty easy reach. It just starts with a good design, good label design. Based on history, I can tell you that processes in manufacturers change, people come and go, and so you're probably going to be dealing with this type of issue continually over the future years. And getting feedback to the manufacturers now is important to establish the culture of what you actually need. And what you need is good, scannable, reliable, repeatable barcodes. You'll eventually probably develop a trust in some of your manufacturers that allows you to assume that they are producing good stuff. Some tips for good barcode practices. First of all, bigger is better in barcode. So when you look at barcodes and you see a large X dimension, that's the narrow bar, and you compare it to another barcode that has very small bars, you'll know that this larger barcode is easier for the scanner to see than this one. So bigger is better. Also, barcode height, the height of the bars themselves. If you have laser scanners being used, then the laser beam has to be angled at the same orientation as the barcode itself. So very short barcodes are more difficult for a laser user to zero in on. About two-dimensional barcodes, these have a built-in redundancy, whereas a linear barcode, if you can destroy it by a crease and stuff like that, but a 2D barcode has redundancy that correct some of those types of problems. And in healthcare, we're using data matrix ECC model 200, which is the error correction coefficient that gives us about 25 to 30% redundancy. And that means that some of these dots in the middle can be obliterated, scratched off, and it'll still read fine. Okay, these two barcode types are code 128 and data matrix. These are the two symbologies that both UDI and DSC, DSCSA are using. And these two could be good choices for your other applications in the hospital, like lab samples, as I showed here, and maybe also things like wristbands, which we have here. There's a lot of different types of wristbands that are out there. And some are using data matrix, some are using linear barcodes, but I would suggest data matrix. So those are good choices. And then that allows your IT people to narrow the range of possibilities that are in use in the hospitals to data matrix and code 128. And that makes their job of maintaining the scanners and helping you out a lot easier. Another thing about standardization is since we have identified that data matrix is part of your future, it's one of the DSCSA, UDI types of codes, the types of imagers that you're going to be using in healthcare are going to be imagers, not lasers. Lasers cannot read these types of codes. Lasers can only read the linear barcodes. So when you're going to purchase these codes or these scanners, focus in on imager-based scanners. Another thing that might help is that if you want to kind of do things like the supermarket does, where they have a fixed scanner in a fixed position, you can do that. Some of these scanners come equipped, well, actually almost all of them come equipped with a thing called presentation mode, where when you put something in front of them, a barcode, it recognizes that there's a barcode there and it proceeds to scan automatically. So imagine this in a fixed scanning or a fixed cradle, and you just put your barcodes in front of it. Let's put 128 in front of it. So it read it. I didn't push the button, by the way. I don't know if you can see there. Same with 2D codes. So that's a good choice for instance, operating rooms or nurses' stations where the nurse may be wearing sterile gloves and she doesn't want to take the glove off and things of that nature, or she doesn't have an extra hand, which is most often. So this presentation mode is in most scanners. Some call it smart stand, some call it presentation mode. A variety of different terminology is used, but it's available on most scanners. So I'd search for that too. And it still can be used by hand. You can still squeeze the trigger and use it that way. And I kind of talked about the two symbologies that are used in healthcare. And the reason I did was because these scanners typically have somewhere north of 40 various symbologies built into them. And it's good to turn off the ones that you don't use. The more you have left on, the more work the algorithms have to do to find the decoding algorithm for, in this case, 128, or in that case, data matrix. So you can improve performance of the scanners by turning off the symbologies that you don't want. And that also makes it easier for the IT guys to maintain an inventory of scanners that perform at a high level. If you're purchasing scanners, I think you want to test scanners in the configuration that you're going to use, like with the symbologies turned off and in the smart stand mode. Make sure that you're getting what you're shooting for. And I talked about the IT managers. I'm not sure if the IT managers in your hospitals are going to be responsible for the scanning. They're certainly responsible for the data that's going into the systems, so they may be responsible for the scanning. And they may already have verifiers that are used to test their barcodes. They may already have some problems and issues and stuff like that, but we would recommend that that is a tool that they would benefit from in every hospital, just to make sure they're doing it well, getting a good grade. So this video was designed to help primarily with the point of care and use of barcodes, wired or wireless in point of care. And hopefully it helped you. We're open to suggestions as to how to extend this to help more, and we're always willing to answer any questions or provide additional information. Just let us know. Thank you.